Hello and welcome to the lecture. So in this lecture we are going to start a new topic, and the new topic is valence shell electron pair repulsion theory, or in simple words we call it as whisper theory. And whisper theory, it is the most valid theory which helps us to predict the geometry and shapes of the molecule, and it takes into account both electronic factors into consideration while predicting the geometry of the molecules. So the main postulates of whisper theory are that shape and structure of molecule, it depends on electrons in the valence shell. So whenever we try to predict the geometry of a molecule, we should take into consideration what are the electrons present in the valence shell of the central atom. So valence shell present in the outermost shell of a central atom, it helps us, or it determines the geometry of a molecule. And so we have to consider the electronic factors while predicting the geometry of the molecule. And since as we know that in the molecule, when a molecule is formed, it is formed and there are formation of bonds in the molecule. Now both lone pairs and bond pairs, they combinedly predict the geometry of the molecule. So it means that there should be a repulsion, because electrons, they try to repel each other. So lone pair repulsion, it is greater than lone pair bond pair and bond pair. So in order to minimize repulsion, that is, the lone pair they should be away from each other, and lone pair bond pair, they should also be, they align themselves in such a way that the repulsion, it is minimum. So in the molecule, their lone pair repulsion, it is maximum. Lone pair repulsion, it is maximum in the molecule. So if there are two lone pairs present in the molecule, suppose an example we will consider that if there are two lone pairs present in the molecule, then those two lone pairs, they will align themselves in such a way that they should have minimum repulsion. So that is why lone pair repulsion, it is greater than lone pair bond pair repulsion, followed by bond pair repulsion. So this thing, it should be taken into consideration while we predicted the geometry of the molecule. Now what is the effect of lone pair in the molecule? So we have when we try to take a lone pair into consideration, so there are two things. One is geometry of the molecule, and another is shape of the molecule. So geometry, it is defined as internal arrangement of electrons around the central atom. Geometry, it is defined as internal arrangement of the molecule, internal arrangement of electrons around the central atom. So shape, so we have, if in the molecule there are 0 lone pairs, that is, lone pair is equal to 0, then at that time geometry, it will be equal to shape. When lone pair, it is 0 in the molecule, at that time geometry, it will be equal to shape. But if lone pair is not equal to 0 in the molecule, then geometry, it will not be equal to shape. Suppose we have a molecule, a hypothetical molecule AB3, and its shape, it is having the geometry of trigonal planar. Suppose it will be looking like this. Now here for this atom, the number of lone pairs, it is equal to 0. It means that for this molecule, both shape and shape, it will be equal to geometry. Shape, it will be equal to geometry, and it will be trigonal planar. So why? Because for this molecule, lone pair is 0, so geometry, it will be equal to shape. Now if we have another molecule like this A, B, 2 type, and it is having a one lone pair. Now if I draw the structure for this molecule, it will be looking like this type with one lone pair. So for this molecule, there is lone pair equal to 1. So it means that shape, it will not be equal to geometry. Now for this molecule, geometry, since geometry, it is the internal arrangement of the electrons. So for this molecule, the geometry, it will be trigonal planar. But if I had to predict what its shape is, for this molecule, shape, it will be equal to bent shaped or V-shaped. So and what actually from the electronic arrangement around the central atom, we can predict actually what the geometry of the molecule is, what the shape of the molecule is. If lone pair in the molecule or lone pair in the central atom, it is 0, and at that time we can say that geometry, it will be equal to shape. But if there is lone pair present in the molecule, at that time geometry of the molecule and shape of the molecule, it will be different. Now for predicting what actually, how can we predict the geometry of the molecule is, we should have a concept of steric number. Now for calculating the steric number,